We are doing quadratic formula today. You need out worksheet 10, and you're going to need a calculator. These standards are probably small and blurry. It says we're going to talk about what the discriminant is and use it to predict the number and type of solutions to a quadratic equation. And then we're going to actually solve the quadratic formula. You might have to simplify radicals, and you might get some solutions that have i's in them. Are we feeling ready? Everybody find worksheet 10? I'm going to do things kind of in a wonky order today, I think, because it really makes sense. I've decided since I wrote the worksheet that it makes sense to talk about the discriminant first, but we'll see if it helps or not. Okay, I got some warm-ups, I promised. Quick, these are icky numbers, not necessarily ones I'd use on the quiz, but you see this cubed here? That usually indicates these are a cube of something, okay? So anybody know what 343 might be? Or yeah, otherwise the cube root on your calculator, okay? There is a cube root button on your calculator. It is under the math menu. Under math here, and there's cubed root is choice 4. So you could, whoa, I'm not in the home screen, sorry. Math 4 is cubed root, 343, is that what I wrote down? Is 7, okay? That's how you would do that on the calculator. I'm not planning to use crazy big numbers on the quiz, but okay. Anybody try 216? It is 6. So how does this first parenthesis go? 7p, and we do what with the sign? Minus, okay. Next parenthesis, the signs are going to change to opposite and always positive, right? Okay, then we have to do this one squared, which would be, anybody? 49p squared, because you got 7p times 7p. In the middle goes one of these times one of these, so what is a 7p times a 6? And at the back goes the b, the 6 squared. Okay, and it does not factor further. Big messy numbers, but okay. Then I promised I'd keep working on 0.3. Equation perpendicular to this through this point. Okay, I was really cruel today because perpendicular to that, we don't even know what the slope of this is yet, right? So if we subtracted the 5x over to the other side, and then we'd need to divide everything by 2 to even figure out what the slope is. The slope is a negative 5/2, and I don't care about this number back here at all because all I want is the slope anyway. So the slope was negative 5/2. Other than that, I didn't care about anything. But what is the perpendicular slope then? Yep, positive 2/5. And now we got to use this lovely point. So we're going to go y minus y sub 1 equals mx minus x sub 1, where this is our x1 and our y1. So what will that say? Y minus 7 equals our new slope of 2/5, x minus negative 4 or plus 4. Okay. Y minus 7 equals, if we had to distribute, if we're trying to get a different form, we would distribute. Remember, this is a 4/1. If it wanted slope-intercept form, we would need to add the 7 over there. Anybody catch me making a mistake? Am I doing okay so far? I haven't done this one before. I just made it up before class, so let me know if I did something wrong. Y equals 2/5 x. Can you type 8 divided by 5 plus 7, maybe 43/5? It's probably wrong. Is that right? Okay. I'm just going to stop. We could do standard form, but we'll practice that next week again. 5 minutes of warm-up is plenty. All right. Moving on. I am going to start at the top by talking about quadratic formula, but then we're actually going to jump to the back and talk about the discriminant before we practice this. Everybody good? Now, quadratic formula is actually, it's kind of a whole theorem. It says if ax squared plus bx plus c is equal to 0. Okay? So a is on the quadratic term, b is on what we call the linear term or the plain old x, and c is the constant. Now a, b, and c can be negative. They don't have to be positive. Then you solve this. Someone can shut that door. That would be great. And you will find the value of x that works by taking, okay, the opposite of b. If b is positive, you change it to negative. If b is negative, you change it to positive. Opposite of b, plus and minus, there's two separate solutions we're talking about here. The square root of, now you have to square b. If it's negative, you will need parentheses. So I just always write the parentheses, b squared. And then this back here is minus 4. And the 4 is part of the formula. Okay, it's not a 4 from anywhere in the equation. And then times the a value times the c value. And it all goes over 2 times the a value. And I hope you remember this, but when you have a fraction bar, everything on the top and everything on the bottom have to be done separately before you can reduce, okay? Now, we're going to get to a favorite meme of mine today that I don't think I remembered to put in the slides. It's this poor little kitten. I love kittens. Not a cat fan, but kittens are adorable. But it says every time you do this, you kill a kitten. You cannot reduce things, okay, unless it is a factor you can reduce out of everything. Let me give you a better example than that. When we're doing quadratic formula, I don't know what I just did. Did I just go to a new page? I can't even see what's under there. Okay. Yes, I went backwards. Okay. I want to add a page. There we go. Sorry. When we get to this point in the quadratic formula in a minute, somebody's going to do, well, this goes in here, and then this goes in here, and that's totally wrong, okay? When you end up with this, that's killing kittens because you're reducing things you can't reduce. This is all glued together, and it's over 4. If you want to unglue it, there's a couple things you can do. You can factor a 2 out of the top, or I usually teach students to write it as 2 separate parts, because then you can reduce each part and it's kosher, it's legal, okay? So this would reduce to -3/2 and this would reduce to 1/2, because there's no longer this plus or minus gluing things together up here. It's into 2 fractions. All right, now that I've gotten off on a sidetrack, we're going to go ahead and talk about, all right, let's do one quadratic formula first, and then we'll talk about discriminant. I'm going to jump around. Let's do number 3. What are a, b, and c? Remember, it's a, in this case, it would be n squared plus b n plus c. So what's in front of the n squared is a, and that would be 3. On the n is a what? -1. Yep, we're going to go with this whole thing is a -1. And then what is c at the back? The constant is -24. All right. Then we're going to go x equals, whoops, in this case it would be n equals. Opposite of b plus or minus, I'm just putting it on the screen here, b squared minus 4ac all over 2a. Okay. What is the opposite of b for this question? +1 plus and minus the square root of. In the parenthesis, it is -1 for the b squared, okay? Minus 4 that comes with the formula times a, which is 3, times c, which is -24. All over 2 times a. All right, I want to do just what's underneath the radical first, because you have to find, that's where the discriminant is. That's what's called the discriminant. So you're going to type -1 in parentheses with the squared on the outside, minus 4 times, I already forgot what the numbers were, 3 times -24. Everybody see how that goes? I got 289. How we doing? Anybody not getting 289, please be typing. Please grab your calculator and be typing. And in the denominator, 2 times 3 is 6. Now, does anybody recognize 289? Yes, good job, Bella. It's the square root of 289 is actually 17. Okay, so this is a perfect square. That's would probably be the first thing I would try, is see if it actually square roots, and this one does. Now, I would suggest you just write these separately. 1 plus 17 over 6 and 1 plus, minus 17 over 6, because we're going to get 2 real answers. This one is 18 over 6, which reduces to what? 3, and this one is negative 16 over 6, which would reduce by 2 to negative 8/3. This was 18 over 6. Okay, how we doing? Now, the fact that we got 2 nice answers, sort of nice, actually means that this would have factored. But you have to solve the way I ask you on the quiz and show your work. And you're not going to know till you, some of them you wouldn't recognize whether they factor or not. All right. I'm just going to keep going. All right. Let's skip down to number 6. Okay, let me move this. It's not recording that very well. There we go. All right, can I move that? No. What are A, B, and C on your number 6? Sorry, it's really tiny up there, but can you see on your paper? A is 3, B is the linear term of -4, and C is 6. Antoine, you okay? Okay. Then the formula goes the opposite of B, which would be +4, plus or minus what? It's really easiest if you can just square the B in your head when you write it down, because then you don't have to worry about the parentheses. Do you know what -4 times -4 is? 16. Otherwise, you have to write -4 all in parentheses, squared, and then it's -4. And you're clear that that's part of the formula, right? That's not a 4 from up here anywhere. And then it's times A, which is 3, times C, which is 6. all over 2 times a, which happens to be a 3 again. All right. So now we are either typing we cheated and did it faster than this, which I would have just done 16, but then it was minus 4 times, what was it, guys? I already forgot. 3 times 6? Negative 56. Did someone else get that? Okay. Now what do we have to do? What did we learn yesterday? Or we did a little bit of. Elo, did you have an idea? No? I thought I saw your hand, sorry. Yeah, we're gonna need an I, perfect, okay? To get that negative out of there, we're gonna make it 4 plus or minus I. Now that takes the negative 1 out. It's still 56, but can we break 56 down at all, guys? It's 8 times 7, but 8 is not a perfect square. What perfect square goes into 8, though? 4. So 4 must go into 56. Can you try 14 times? Okay. So square root of 4 would be 2. Square root of 14 can't simplify. It's 2 and 7, and neither one of those are perfect squares. Okay, this is not how we would normally write this. Okay, we would write 2i square roots of 14. But we're going to break it up so we don't do any crazy killing of kitties, and we're going to put each piece over what? 6. So what is, now, you can only reduce things that are not in jail. This little irrational jail here, you need to leave that 14 alone, okay? The only way you can reduce that is if you can bring something out front by perfect square. But 4 over 6 reduces to 2/3. And 2 over 6 right here reduces to 1/3. So you would just have I square roots of 14 over 3. Now, some of you could have realized you can reduce all of these pieces by 2 back here, but I find that some students will make mistakes, so I would rather you wrote it like this. It is equivalent to 2 plus or minus I square roots of 14 all over 3, but this separated piece is less likely for you to make mistakes. All right, we're going to try number 7. Did somebody need more time writing that down? Can you get started on number 7, guys? Make sure B is -1. So the opposite of B, plus or minus that same B squared minus 4 times A times C all over 2A. And you have to memorize quadratic formula. That's the first question on the quiz for that section, is to write out the quadratic formula. I would think you've had to memorize it before now. So N equals, opposite of B is 1. B squared minus 4 times A, which is 4, times C, which is 5. Is it something disgusting like -79? Did someone else type that in? Is anybody not getting -79? Okay, so this is actually a pretty nice question in my opinion, because 79 doesn't simplify, right? So the only thing we can do is what? We have to take out the I, or the square root of -1. So we'll end up with 1 plus or minus I square roots of 79 over 8, and nothing reduces. All right, I wrote down here that we should do both 8 and 9. What's going on with number 8? Something's wrong. We can't deal with this the way it's written. Okay, it's got to equal 0. It has to be in the form for both of these of ax squared plus bx plus c equals 0. Now, it doesn't matter if the 0's on the left or the right side of your equation, but it's got to equal 0. I'm actually going to move these over to the left because I like a positive squared term. So I would have 9x squared plus 4 equals 8x, and then when I subtract the 8x, whatever order you want to do it in. Did everybody get a 9x squared, a minus 8x, and a plus 4? If you had the opposite signs, because you moved it the other direction, you got a -9, a positive 8, and a -4, you'd get the same answer in the end, okay, if you did it right. All right. Here we go. A is 9, B is -8, and C is 4. So the opposite of B, anybody nice and loud? 8 plus or minus, you want to just square it when we write it down? What is -8 times -8? 64. That was our B squared. And then minus 4 times A, which is 9, times C, which is 4, all over 2 times 9. Is this another one with an I? We get 8 plus or minus, I don't know what that is. 64 minus -80. Okay. Well, this one's good practice because we're going to have to do some simplifying. And the denominator is 18. All right, I'm going to leave the 8 over 18. And plus or minus, this is also going to be over 18, but we need to do some stuff with that. Okay, it's the square root of -1, or I. What goes into 80? Yeah, 4 goes in. If you did 4 times 20, would you have recognized that 20 breaks down again? Okay, and you could do that. You could say it's 4 and 4 and 5. But then you'd get a 2 and a 2, and you'd get a 4 square roots of 5. It's easier if you realized 16 went in there 5 times, because what is the square root of 16? 4. Square root of -1 is I. Square root of 5 you can't deal with. How would we normally write that? 4I square roots of 5. Yep. You would have got there the other way, hopefully, but you always want to find the biggest perfect square that divides in if you can. All right, let's finish reducing. What do we get? 8 over 18 reduces by 2 to 4 over 9. 4 over 18 reduces by 2 to 2 over 9. And that has an I square roots of 5 up there. I'm going to look at number 9. Number 9 is another imaginary one. I don't want to do that one. Do I not have one with a 0? All right, we can practice a couple more in a minute, but let's go on and talk about discriminants. Can you go to number 12 on the back? When we are doing quadratic formula, if we get a value in the radical that is negative, so it said opposite of b plus or minus some negative radical over 2a, what kind of answer are you going to get? Oh, that's greater than 0. That says positive. Just kidding. I wrote that in the wrong spot. Let's talk about if it's positive first. What happens when you go to solve that? You get two answers, right? You can do plus the answer and minus the answer. Okay? If you were to graph that and it had two solutions, the parabola would look like this. Do you remember that anything with an x squared is a parabola? We haven't talked about the graphs yet. Okay, so this would have two real solutions. So what we just found out, the discriminant is the part that's underneath the radical. It does not include the radical. B squared minus 4ac is the radical. Is the discriminant. I just said that wrong. B squared minus 4ac is the discriminant. If that discriminant is positive, you would end up with negative b plus that radical over 2a and negative b minus that radical over 2a. Two solutions. If the discriminant is 0, which I apparently don't have an example on here, you would end up with the opposite of b plus or minus the square root of 0 over 2a. Well, when you add and subtract 0, do you get two answers? Guys, if I said negative 3 plus and minus 0, you just get negative 3, right? One answer. Okay, so this is one real solution. If you were to graph the parabola, it would have something like this. It would sit right on the axis, or this. Do you know what I'm saying? It would only touch the x once, okay? Either this or this. And this one could have gone down over here, but it has two x-intercepts. If the discriminant is negative, so you do opposite of b plus or minus, and you get a negative number in here, okay? How many solutions do you get? You still get two, but what kind of numbers are they? Means they're going to have what in them? An I. So you can write two imaginary or complex solutions, which also means no real solutions. And I actually wrote out the choices for that on the quiz. It says two complex, no real, two real, or one real, so that I gave you the choices and you didn't have to think about that, what that meant. Now, the graph for that, guys, if it has no x-intercepts, the parabola could look like this, or it could be way over here, but it doesn't ever cross the x-axis. Okay? Trying to tie this into what we're going to do next week with graphing. The most important thing is that you understand the discriminant does not include the radical itself. It's just the number inside. So let's do a couple examples. Number 13. This is a gross one, but right now, A is negative 2, B is negative 4, and C is negative 2. Everybody okay with that? So we would write down the discriminant is, all you want is b squared minus 4ac. You're not going to do anything else. So you do negative 4 squared minus 4 times a times c. Whew. Can we put that in our calculator? . think it should come out 0 because this is 16 minus 4. If you just multiplied those, you'd get 4. Is it 0? Did someone else get 0 on the calculator? Okay. So if we add and subtract nothing, are we going to get two different solutions? No. This is one real solution. We stated the number, we found the discriminant. This would be your whole answer right here. You told me the discriminant is 0 and the number and type of solution, there's 1 and it's real. I'm going to skip down to number 15. Can you try this one? A is -6, B is 9, and C is -7. So B squared minus 4AC would be 9 squared. We really don't need parentheses because it's not negative. Minus 4 times A, which is -6, times C, which is -7. I think that's going to be positive, but 9 squared. I hope you're typing because otherwise it's -4, but then it's times a -6 times a -7. I got a negative. Oh, because, yeah, okay, this is 81 and it's -4. When you multiply those, you get 42. Yeah, so it is, okay, it does, I got -87. Sorry, I misled you there. Great job on the video, Hofbauer, making a mistake again. All right, so the discriminant is -87. So if I were doing this and it was under the radical, that would give me some i's, which means what kind of answer are we getting? Okay, no real. Or you could say too complex or imaginary. All right, what have we had so far? A 0 and a negative? Okay, 17. What's the first thing we have to do here? Yeah, it's got to make it 0. Good job. 2m squared plus 3m. We move that 2 over their side. It becomes -2 equals 0. So can I skip writing it out? B squared minus 4 times A times C is -2. Which is going to become 9 plus 16. Anybody get 25? Okay, you can just type it like this. You don't have to, I was just trying to break it down so I could do it in my head. Became 25. So actually this would have two rational answers because it's a perfect square, but as long as the rational numbers are also real. Positive D value means it has two real solutions. When you square rooted it, you get 5, right? So you'd have opposite of B plus or minus 5 over 2A. So what is the purpose of the discriminant? Well, it's just a predictor for how many solutions you're going to get. Okay. It is asked about on the quiz. What do you want to see? You want to go back and do one more? Your homework is on Delta Math tonight. You are also welcome to finish this worksheet if you need more practice. Yes. Yes. This is the big deal, guys, on this little slide right here. If it's greater than 0 or positive, you answer 2 real solutions. If it's exactly 0, you answer 1. If it's less than 0 or negative, you answer no real and 2 complex. Yes.
On the last page, number 5, it doesn't have a B.
Okay, we can talk about that one. It would be 0. And honestly, I don't think I would probably solve that using quadratic formula, but I'll show you. Are you good, Adriella? This number 5, you could say it is 4k squared plus 0k minus 3 equals 0 if you wanted to do quadratic. I would have just moved the 3 over to the other side, since there's no b, divided by 4, and then square rooted both sides. What would you get, guys? Very important. What would you not forget? It is square root of 3, and the square root of 4 is just 2, but it would be plus or minus. Do you want me to show you the whole quadratic formula way, what it would look like? Okay, no. I'm gonna do this number 4 on this screen just because I'm here. A is 1, B is 1, and C is -1. So the opposite of B would be -1 plus or minus the square root of 1 squared minus 4 times 1 times -1. All over 2 times 1. So I would get -1 plus or minus. A negative times a negative is going to be a positive 4. So 1 plus 4 is... Boy, it'd be real nice if I put one of those on the quiz, which I think I did. Because you didn't have to do any like crazy simplifying, right? I think there's one on the quiz where you don't have to, and then there's one where you do have to do some radical simplification or simplifying with an I or something like that. More? Yes? No? We okay? I know that when Delta Math pulls up a problem, or even on your homework, there's a thing called Photomath, right? And it will solve this for you and probably even show you all the steps. But is that going to help you get it right on the quiz? Okay. I did not assign a ton of practice on the Delta Math, okay? I assigned a reasonable number, like 1 of each kind or something, and a couple discriminant questions. If you don't feel comfortable, you can do extra Delta Math. You can do extra practice. You can finish this worksheet, and the worked out answer key I think is in Google Classroom. I'll make sure it is. The ones I skipped. Okay, but there is Delta Math. First and foremost, do not try to do the Delta Math without paper and pencil. That is not to your benefit, okay? Definitely you should be doing some work on scratch paper. I haven't gotten to the point where I'm going to require it yet, but I know some teachers who are assigning Delta Math is, like on the homework check, you would have to attach your scratch paper for Delta Math. I just didn't get that far. I figured I'm going to...
My scratch paper is so messy.
Yeah, and I'm really,